Today we're still talking about lesson 2.2, so this is actually lesson 2-2 continued. The notes that you take today, I want you to take them in for the first two parts that we're going to go over. I want you to actually turn to the last 2 pages of your notebook right now, and I want you to take them in the last couple pages of the notebook. You can take them on the front and the back, and hopefully that should give you enough space to take them. The reason I want you taking them in the back is because I want you to be able to refer to these every time you need them very easily until you get really good at this. If you can learn what you're going to learn today really well, you're going to be able to use it for the rest of the year all the time. This is decimal busters and fraction busters. And it's really important to realize that both of these can only be used when we're talking about equations, not expressions. And I know a lot of times people get a little bit stuck once they come across especially a fraction in an equation, sometimes decimals also. And this is a way to eliminate those fractions and decimals right away, which can really make it easier to solve some of these equations. So the first thing we're going to look at is decimal busters. Remember, go to the very back of your notebook to do this if you're using a notebook. So, decimal busters, I'm going to go ahead and do the example and then we'll write on the left. I come across an equation that says solve 0.5a plus 8.75 equals 13.25. Now, notice when I wrote this out, my decimals are very distinct as decimals. Make sure you're very careful about that. It's really easy to confuse things if you aren't. So typically, if we were solving this equation, you would draw your line. Here's your variable. You're trying to isolate that a, so first you would subtract 8.75, then you would divide by 0.5. And I know sometimes some of you end up making calculation errors there, even if you already know how to actually solve that. So there's a little shortcut you can use when you have these fractions, or these decimals, if you want. And the key again that I said is it can only be used in an equation. And the reason that that's the case is because of that rule, kind of like what we've been doing when we've been solving. If I subtract from this side, I have to subtract from that side. So it's that same idea. You're not really changing the value of the equation if you are changing everything at an equal amount. So the steps to do this is you need to look at, okay, what could I multiply every term in this equation by to get the decimals to move over a total of 2 places? Because if I notice this one has 2, this one has 2, this one only has 1, but I want to be able to move them all the way over. If I multiplied by 1 place, I wouldn't move it out of these 2. So you're always looking at the largest amount of numbers you have behind a decimal, and that's how many places you're trying to move it. If we think about values of 10, you multiply by 10, it ends up moving the decimal over 1 or adding a 0 to a number. If you multiply by 100, it ends up moving it over twice. If you multiply by 1,000, it moves it over 3 times. So you're looking for some kind of value of 10 that you can multiply every term by to move those decimals out. So here's your steps. Find the term with the most You're going to find the term with the most decimal places back. Okay, so in this case we have 2 of them that each have 2. And then you're basically multiplying by a value of 10, like I said, or easy way to think about that is that you're going to move the decimal in every term. This is the key right here. It has to be every term, even terms that were just whole numbers. Like if this was a 5, I would still need to move it 2 places, so it would become 500. So every term, that number of places. If you run out of places, then you're going to add zeros. So add zeros for place value when needed. This is key. People always forget that part. It's not worth using a decimal buster if you're going to use it wrong, because I know every single one of you knows how to add, subtract, multiply, and divide decimals. This is just like a shortcut that you can use to make life a little bit easier when you're solving some of these equations. But if you're not going to use it correctly and remember this key part in here, then you're going to get every one of them wrong, and you'd be better off just going with the decimals. So let's just do a couple examples in case you're a little bit confused about that. So for example, if I wanted to move 2 places, I wanted to move everything back 2 places, which means multiplying by 100. If I had 0.2, it would move 2 places, so 1, 2, I have 1, and I add a 0 for 2. If I had 5, it would be the decimal would be behind the 5, so I have a 5 and I add 2 zeros. If it was 0.63, 2 places, I'd have 63. If it was 0.474, now when I move it 2 places, notice my decimal didn't go away yet. So if you had a problem like that and that happened, then you would know that you needed to actually move it 1 more. Everything would need to move 3 places instead of 2. So let's try a couple examples with that. Hit pause if you're not done copying. Okay, so right here I'm still going to think about the fact that I've got this line here, this imaginary line there. And now I figured out that the largest place value I had back here was in the hundredths, so I'm going to move everything over 2. This one goes over 2, it becomes 50, so I have 50A plus 875 equals 1,325. So I moved everything over 2, I multiplied everything by 100. Now I have an equation that I'm going to solve with the way that we've been solving it. So I'm going to go ahead and subtract 875 from both sides. That term cancels, becomes a 0. I have a 50A equals 450. This is multiplying, so now I'm going to go ahead and divide. This becomes a 1, and I have A equals 9. And then again, you can plug 9 into the original if you wanted, or you could plug it into this as long as you're positive that you did your decimal buster correctly. But if you think you did your decimal buster wrong or you're worried that you made a mistake, plug it into the original and see if it works. If it doesn't, your mistake probably came in here if you thought you did it wrong. So that's the checking portion of it. Alright, let's try one more. I'm going to write it down. You try to figure out how many places you need to move everything over and rewrite the equation. Hit pause and then listen to me to make sure that you understand how to do that. So we're solving again. 0.025x plus 22.95 equals 23.65. So look at that. Think about how many you should have to move everything over. Rewrite the equation, hit pause while you do it, and then hit start when you're ready to go. Alright, so we drew our line. We looked for our variable. We only have 1, so we only have to worry about that. I counted my decimals and I noticed I had 3 here, 2 here, 2 here. So my largest number was 3 places. So I'm going to have to move everything back 3 places. So I move this back 3 places and I just get a 25. So 25x. I move this back 3 places and I need to add a 0. So it actually becomes 22,950. Equals, again, I need to move it back 3 places, so I have 23,650. Now I'm going to go ahead and solve just like I've been solving all of the other equations. So subtract 22,950 from both sides. Remember, I want to see your signs. I want to see what you're doing there. And I have 25x equals 700. Then I'm going to divide both sides by 25. That becomes a 1. So I just have x equals 28. And then again, to check, you would evaluate with 28 in here or in here. And on your homework, if you want to check those with your calculator really quick while you're practicing these tomorrow in class, that's fine, because I'd rather have you making sure you're doing them correctly while you're practicing. Now we're going to look at fraction busters. Fraction busters you'll probably use even more than you'll use decimal busters. So start this on the other page or on the back of the page you used for decimal busters. And again, they can only be used for equations. Not expressions. So just be really careful with that. Later on when you come across expressions again, you don't want to start using that. This is example 1. Solve 2x over 3 plus x over 2 equals 7. So notice in this case that you have the variable here and here. And you also have 2 fractions. You can use a fraction buster even when you only have 1 fraction. It really doesn't matter. But this is going to be difficult because if you notice, you need to be able to combine these terms, and in order to combine the terms, you have to have a common denominator, and then you're going to end up with a fraction there. So it's not impossible to do. You can do it, but I know some people don't like to have to deal with it. So this is kind of your shortcut here. You're going to take the same approach that you would take if you were finding a common denominator. So just look and say, okay, what would my common denominator be that I would be converting these to? Hopefully everyone noticed it's 6. And then you take that common denominator, that LCM, it's your least common multiple, the first thing they both multiply to be, that's your LCM. So you identify your LCM and you can write it. LCM is 6. Once you have that LCM, you're going to multiply the LCM to every term in your equation. So I'm going to rewrite the equation in green again so you can kind of see what happens here. So I have 2x over 3 plus x over 2 equals 7. Every term. There's a term, there's a term, there's a term. So I'm going to multiply this by 6 over 1. I'm going to multiply this by 6 over 1, and I'm going to multiply this by 6, or 6 over 1. Now, if you notice and you use your rule for cross-canceling when you're multiplying, 3 goes into 3 once, 3 goes into 6 twice. 2 goes into 2 once, 2 goes into 6 3 times. Now you're just going to simplify. I have 1's across the bottom of my fractions. That was the whole goal there. So I have 2 times 2x, which is 4x, x times 3, which is 3x, equals, and then you just go ahead and multiply this, 42. And now you have no fraction. So everyone should know what to do with this. Draw your line. You have like terms, so you're going to go ahead and just add them because it's addition. So you end up with 7x equals 42. Now you have multiplication, so you're going to divide. X equals 6. It's not always going to end up being your LCM. That just happened in this example. So don't expect these answers to be the same every time. Alright, so let's write down a couple notes about that. You're going to get a lot of opportunities to practice this tomorrow in class and ask me questions about it. It's really important that you get good at this. It's going to make life a lot easier for you in algebra this year. So the steps you're going to follow is first to find the LCM, which you would have done if you were going to make a common denominator here anyway. Remember, LCM is least common multiple, not factor. Factor is what you can divide into them. This is multiple, what they multiply to be. And this is the important part, the LCM of all denominators. Even if they're on the other side, if you have a denominator on the other side of the equation, it needs to be of every fraction in there. Then you're going to multiply the LCM to every term on both sides of the equation. And it doesn't matter if it's a whole number, if it's just a variable, whatever it is, if it's a term, you're multiplying by that. Okay, and here's the key. The fractions should cancel out. If they don't, you made a mistake. So if those fractions don't cancel, you know you did something wrong. Go back and look at your multiple again. Make sure that you figured out the correct multiple. And now you're going to solve. And a lot of students I notice get confused because their answer becomes a fraction. You can have a fraction as an answer at the end. It's just you wiped out the fractions in order to solve here and make it easier. So if you get down here and you divide and 42, let's say that was 43, then that's okay. It's 43 over 7, and you can either leave it as 43 over 7 as an improper fraction, or you could make it a mixed number. But fractions in your answer are fine, so don't get confused if that happens. And then of course you can always go check this. And I'm just going to go ahead and check it since we're all doing it together here. But when you're doing your work, you should always plug it in down here and check it. 2 times 6 is 12. 12 divided by 3 is 4. And then we have 6 divided by 2, which is 3. 4 plus 3 is 7. So we did that correctly. Alright, let's try one more. We're actually going to do 2 more. Example 2. Solve m over 4 plus m over 2 equals 5 over 8. So take a look at your denominators and find out your LCM. And hopefully you all saw that your LCM here is actually 8. So don't go up to 16 because 4 goes into 8, 2 goes into 8. So 4 times 2 is 8, 2 times 4 is 8, 8 times 1 is 8. So your least common multiple is 8. If you were to multiply that by 16, it would have worked. You just have larger numbers to deal with. So sometimes it's nice to go ahead and find the smallest numbers possible. So now you're going to go ahead and multiply every term by 8. So times 8 over 1, times 8 over 1 times 8 over 1. And then you can cross cancel things. So there's 4 goes into 4 once, 4 goes into 8 twice. 2 goes into 2 once, 2 goes into 8 4 times, 8 goes into 8 once. And now you're going to simplify. 2 times m is 2m, plus 4 times m is 4m, equals 5. Now I have like terms here, so I add them up. I get 6m equals 5. Divide both sides by 6. M equals 5 over 6. So your answer is 5 over 6. This is what I was talking about in the last one. You can have a fraction in your answer, but it was still a lot easier to solve the equation without the fraction in it. Alright, let's try one more. The last one, we don't have to write anything on the left if you're switching pages. Most of you probably still have room though. Example 3. 2 over 3 x, subtracting 5 over 8 x equals 26. Okay, the difference here, the last problem that we were looking at, or the one before it, let me look here, had the x at the top. Remember, when we write a fraction like this, it means 2/3 times x over 1. So if we were actually to put that together as one fraction, the x would go up at the top in the numerator anyway. Same thing here. So the other way to look at that is 2x over 3 subtracting 5x over 8. This x would have to be under that fraction bar to be in the denominator. So we've got it on the outside, which actually means it's part of the numerator. So all you're going to look at is the numbers. We have a 3 and we have an 8. We don't care about 26 right now because it's not part of a fraction. And so you stop and think about the first thing. 8 and 3 both multiply to b. And you should have come up with the fact that your LCM is 24. So now you go ahead and you multiply this by 24 over 1, this by 24 over 1, and this by 24. And do your cross canceling. You can pause and try it on your own if you want, and then come back and check it. Cross cancel, I have 3, 8, 8 and 3. Now I go ahead and simplify. So I have 8 times 2, which is 16, so I have 16x. Subtracting 5 times 3, which is 15x, don't forget your x's there, equals, and when you multiply 26 times 24, you end up with 624. So now I'm just going to go ahead and solve. There's my line, there's my line. Here's my like terms. Common mistake here, be really careful with this. 16x subtracting 15x, you have basically a 1x, which is x, equals 624. You have nothing else to do because that 1 there isn't negative. If this had been a negative 1, you would need to divide out the negative 1. But it's not, so you don't have to do anything. And that's Fraction Busters. The last thing that we're going to look at today is called transforming formulas. It's a little bit of a side lesson that ties into solving equations. You use it a lot in science, or you might use it in business, just with different formulas to calculate things. And the main thing is that you're going to follow the same rules, but you're going to have a lot more letters. So instead of saying solve, it's going to tell you what to solve for. So in this case it says solve for h, and the equation that they give you is area equals 1/2 base times height. So instead of having numbers plugged in for area and base and then solving for h, you're just going to treat these variables exactly like you would treat a number. Don't let it confuse you. Even if this was a crazy symbol, you would just treat it like it's a letter and you just move it around. So this is where that highlighting comes in handy. Solve for h, that's what I'm trying to isolate. So I'm going to look and I'm going to try to figure out what is everything else here. Well, I have multiplication and multiplication. So we can divide. You can actually divide by 1/2 b, but I know a lot of you might get confused about dividing by 1/2 here. So go ahead and just take it in steps if you get confused about it. I would start by dividing both sides by b, because I know what to do with the b. And now this b divided by b becomes a 1, so I end up with a over b equals 1/2 h. And then again, I'm just going to take it in steps. Here's my variable. I know I need to get that alone, so what's the next thing I could do? I have 1/2 times h. I can divide both sides by 1/2, or I know about that rule, multiply by the reciprocal. So multiply by 2 over 1, multiply by 2 over 1. And then I end up with 2a over b equals, these become a 1, h. And I have h alone. And the reason that you need to do this sometimes is because, let's say you are working out something with area of a bunch of different triangles and you're trying to find the height of each of them. It's a lot easier if you already have this transformed one time and you can just keep plugging in the a and the b, find h every time. If you had the a and the b here, you'd have to do these steps every single time you had a different number to plug in. So that's why it's important to use sometimes and be able to transform it around. Okay, so on the left, just go ahead and write solve for the given variable. So that's what you're trying to isolate. And just remember, you move variables just like they are numbers. So that inverse operation idea. If it's multiplying, you divide. If it's dividing, you multiply. If it's adding, subtract. If it's subtracting, add. Okay, let's try another one. Example 2. Solve for b. And it's ab subtracting d equals c. So again, if you have a highlighter, I would go ahead and highlight this. That's what I'm trying to isolate. So just look at the other letters and pretend they're numbers. If you want, pretend that's a 2 and that's a 5. What would you do first? And hopefully you notice this is subtracting, so you would move it to the other side using addition. There's your line. So I'm just going to add d, and I'm going to add d. They become 0 over here. So now I have ab equals c plus d. These aren't like terms, so I can't combine them. It's just c plus d. Okay, again, now I'm going to use my highlighter. I'm still trying to isolate that b. A is multiplying to b, so I'm going to go ahead and divide both sides by a. And my answer is b equals c plus d over a, or you might see it written as b equals c over a plus d over a. They're both being divided by that a. So if you're going to split it up, you need to make sure that you keep both of them being divided by a. Let's try one more of these and then you'll get an opportunity to practice them tomorrow. Example 3. Solve for f. C equals 5/9 times the quantity f subtracting 32. This is talking about Fahrenheit and Celsius degrees and converting back and forth between them. So the key here, you notice you're going to have to divide by 5/9 or you're going to have to distribute 5/9. This is kind of where that trick from distributing comes in handy, because I really don't want to have to distribute a fraction. So I want to go ahead and stop and think about it and say, well, wait a minute, I remember that rule. This is multiplying to both of these, so I can actually just divide it out one time to the other side, or instead of division, multiply by the reciprocal. So I'm actually going to end up taking this I'm going to rewrite it. And I'm going to multiply by 9 over 5 and by 9 over 5. There's my line going down. So now I have 9/5 C equals, this just becomes a 1, 5 over 5, or 5 and 5, 9 and 9. And now I have F subtracting 32. And again, now I'm looking and I'm saying this is what I'm trying to isolate. So I'm going to go ahead and add 32 to both sides. I don't have a like term here, so my final answer is 9 over 5 C plus 32 equals F. This is how you can find degrees Fahrenheit when you have degrees Celsius. So we'll practice those. We're actually going to practice those throughout the year. They're important to be able to use. So just remember the rule. You can multiply by the reciprocal before distributing. If it's alone on one side. Remember, this has to be alone. I can't have plus 5 or minus 10. I'd have to move that over before I did the distributing. And then once I multiply both sides by that, I'd have to make sure that I was able to multiply that to everything over on the left also, which we might come across a few of those that we can work on. And that's it. See you tomorrow.